In this video, we'll be solving radical equations containing multiple radicals. We use the same property to solve as we did when we had just one radical in our equation. If a equals b, then a to the n equals b to the n. It's still true that if you raise both sides to an even power during your solving process, you need to check your answer, as you may have created an extraneous solution. Our steps are a little bit different. There's a little more work to do since there are multiple radicals in our equation. So you want to start by getting one radical all by itself on one side of the equation. Then you're going to raise both sides to the appropriate power to cancel out the lone radical. Then you're going to clean up your equation. If a radical still exists after you've done your cleanup, you need to repeat the first two steps. You need to get whatever radical is left all by itself on one side of the equation, raise both sides to the appropriate power to cancel it out. Once you've eliminated all of the radicals, then you solve the resulting equation and check your solution if you've raised both sides to an even power, which is going to be the case every time with these types of equations for us. When there's multiple radicals, we're only going to be doing square roots. So step number one is to get one radical all by itself on one side of the equation. We have that. Now we want to raise both sides to the appropriate power to cancel out that square root that's all by itself on the left. To cancel a square root, we square. The most common mistake that I see people make here is that they just square each term individually. You can't do that. On the left-hand side, since there's only one term, it is true that the square and square root are going to cancel out, leaving us with just x plus 1. But on the right-hand side, we have an operation of subtraction inside our parentheses. You can only apply the outer exponent in when the operation is either multiplication or division. If the operation is addition or subtraction, that means that you have to write it twice and multiply it out. Multiplying out our right side, we're going to get 4 minus 2 square root of x minus 2 square root of x plus the square root of x squared. We want to simplify every radical that we can and combine any like terms that we can. Notice that we have like radicals that we can combine. So negative 2 square roots of x minus 2 more square roots of x, that's a negative 4 square root of x. And then we also have a perfect here on the end that we can simplify. The square root of x squared is just plus x. There's no other simplifying or combining that we can do, and we're still left with a radical, so we need to repeat the process. We now need to get that radical on the right all by itself and then square both sides. So we'll subtract 4 and subtract x from both sides. It's going to leave us with negative 3 equals negative 4 square root of x. I'm going to divide both sides by negative 4 to get that radical by itself. We get 3/4 equals the square root of x. Now that that radical is all by itself on the right, we want to raise both sides to the appropriate power to cancel it out. It's a square root, so we square. And whatever we do to one side, we know we have to do to the other side. On the left, the square and the square root cancel out, leaving us with just x. And on the left, squaring 3/4, we get 9/16. Our solution is x equals 9/16. However, during our solving process, we raised both sides to an even power, so we need to check our answer. We're checking it in the original. Is the square root of 9/16 plus 1, is that equal to the square root of 2? That's not right. Is equal to 2 minus the square root of 9/16. So you want to add those fractions underneath. Either use your calculator or get a common denominator. We're going to get 25/16. We want to know if that's equal to 2 minus the square root of 9/16 is 3/4. Simplifying the square root of 25/16, that's 5/4. Subtracting the right side, we also get 5/4. This is equal, therefore our solution of 9/16 is correct. Let's solve the equation. Square root of p minus 6 equals the square root of p plus 2 minus 4. We want to start by getting one radical all by itself. Got it. Radical on the left is by itself. Now we want to raise both sides to the appropriate power to cancel it out. It's a square root, so we square. On the left, the square and the square root cancel out, leaving us with p minus 6. But on the right, because the operation is subtraction between our terms, we need to write this twice and multiply it out. We'll start by multiplying the square root of p plus 2 times the square root of p plus 2. Now typically when multiplying radicals, we multiply what's outside together and what's inside together. If we multiply p plus 2 times p plus 2, we're going to end up getting a quadratic. So we actually want to shift our thinking a little bit. The square root of p plus 2 times the square root of p plus 2 is the same as the square root of p plus 2 squared. Since we're multiplying the same thing together twice, that's what it means to be squared. And what happens when you have the square root of p plus 2 squared? Well, our square and square root cancel out and leave us with just p plus 2. That's what we want to do rather than making this the square root of p squared plus 4p plus 4. That's going to make our life much more difficult. So multiplying the square root of p plus 2 times the square root of p plus 2, we get just p plus 2. Now the square root of p plus 2 times a negative 4 is minus 4 square roots of p plus 2. Negative 4 times the square root of p plus 2, that's minus 4 square root of p plus 2. And then a negative 4 times negative 4 plus 16. We want to clean this up, combine any like terms that we have. Got like radicals in the middle that we can combine, and I also have constant terms that I can combine. We get p minus 6 equals p plus 18 minus 8 square roots of p plus 2. I've combined everything that I can, and I still have a radical left. So now we need to isolate that radical on the right. I'm going to subtract p from both sides and subtract 18 from both sides. It gives us a negative 24 equals negative 8 square root of p plus 2. Continuing to isolate the radical, divide both sides by negative 8. We get 3 equals the square root of p plus 2. Now that we've isolated that square root on the right, we want to raise both sides to the appropriate power to cancel it out. A square cancels a square root. On the right, our square and square root cancel out, leaving us with p plus 2. And on the left, 3 squared is 9. And we want to solve our resulting equation. We'll subtract 2 from both sides. We get p to be equal to 7. Because we raised both sides to an even power during our solving process, we need to check our solution. We'll plug it into our original equation. The square root of 7 minus 6, well, that's the square root of 1, which is 1. On the right-hand side, we'll have the square root of 9 minus 4. We know that the square root of 9 is 3. Is 1 equal to 3 minus 4? It is not. Right? Because on the right, we're going to get negative 1. 1 is not equal to negative 1. Therefore, we need to throw out our solution. And since we only had one solution and we're throwing that one and only solution out, that means that there is no solution to this equation. Had we gotten two solutions and one of them checked but the other one didn't check, we would not say no solution. We would just X out the one that didn't work and circle the solution that did work, and that would be our solution. No solution is reserved for when our one and only answer doesn't work.